Right, so here we are where we left off in the last episode, and we're going to get things moving and add the blades. And the way we're going to add the blades is we're going to stack them on top of each other. For this to work, we need the blade shape to know which blade it's on and how many blades there are in total, so it knows how far to rotate each blade. I'm going to go down to our shape, and I'm going to say we're going to have a current blade, which is an int, and we're going to have a step angle, which is an angle. The reason I'm not passing in the number of blades here is because I don't need to know that. All I need to know is the angle with which we need to change the rotation per blade. So we've got a bit of work to do in our initializer now. We need to add the number of blades here. And because we're high-class photographers, I'm going to give it a default of 9. I'm going to say the current blade is an int, and we'll say that the current blade is equal to the current blade. That's nice and easy. And we say the step angle is equal to 360 divided by the number of blades as a double degrees. That is the step angle that we're going to be using per blade. Now, obviously, the blade that we've got up there at the top doesn't have this information yet, so it's throwing a bit of an error, but we can sort that out in just a minute. But before we do that, let's talk about how we're going to manipulate these layout guides, because you can actually transform layout guides by decorating them with transformations, and the order in which you do that matters in the same way that the order in which you apply modifiers matters, because if you do a rotation and then an offset, that will be different from if you do an offset and then a rotation. So we've got to be a bit careful in the order in which we apply these. But once we've got our layout guides, we can apply these transformations and we can animate them, and it will animate the layout guides for us, and all the work that we've done to create our shapes will come along for the ride. And in this case, all we're going to do for each blade is offset it some and rotate it around depending on which blade we're talking about. And that goes something like this. I'm going to say that we are offsetting by 0.3 of the width of the rectangle to the left. So rect width scaled times minus 0.3. That takes care of the offset. And then we want to rotate it after we've offset it, rotated. And we want to take the step angle times the current blade. Right, that gives us the rotation. Now, if we start using this thing properly, we'll see what we're talking about. So let's fix this by adding a property. Let num blades is an int. We'll adjust the initializer. Num blades, that is an int with a default value of 9 again. Why not? Self num blades equals num blades. And then we can iterate through them on this Z stack. So I'll say for each 0 to the number of blades. We've got our current blade in. And now we can pass in what we want. So we say that the number of blades is the number of blades. The current blade is the current blade. We're already debugging, so I don't need that parameter. Now let's resume and see what that gives us. Well, actually, we've got quite far, haven't we? And it's looking pretty good. So now we need to set things up so the aperture blade shape is an animatable shape, or at least implements the animatable protocol correctly for our needs. And if you haven't seen the episode on custom timing curves, do watch it, because that will make what we're about to do a lot easier to understand, because I'm not going to explain everything that we're doing. The first thing we need is a factor. So this is a variable, factor of type double. And then we say that the animatable data is a double, which we get by returning the factor, and we set by setting the factor to the new value. All right, lovely. But now we need a way to say, what is that factor? Okay, how do we control that factor from the view? There are two ways I'm going to do this, as I'm going to give the option of using an explicit factor or a Boolean saying whether or not we're animating. Let's do the first case where we actually pass in an explicit factor. So I say that the factor, which is a double, is passed in here. And we'll say self factor equals factor. That takes care of the explicit case. I'm going to duplicate that initializer, and instead of factor, I'm going to write animating, which is a Boolean. Okay. And then we say, I'm going to call the other initializer. The factor is going to be controlled by whether or not we're animating. So are we animating? If yes, then it's 1. If no, then it's 0. The number of blades is the number of blades. The current blade is the current blade. And the debug is the debug. Excellent. Nice and easy. So now we can control explicitly or implicitly the animatable factor of this shape. Let's set up the animation here. State private variable of animating, which is false. So we say on appear with animation ease in out with a duration of 2 and repeat forever with an auto reverse of true. We set the animating to true. And then we're going to use the implicit version. Let's set the animating parameter to animating. Now, at this point, we're not going to see anything doing anything for two reasons. First reason is we haven't set up the shape to do anything when we're actually animating. So let's sort out the first thing first, which is the shape. So I'll come down here, and before we do anything, before we offset the blade and before we rotate it, I want to rotate the blade itself around the top bit, okay? Now, this is one advantage to putting these different modifiers or transformations on different lines, because I can just comment them out like that. Now, all the blades are overlaying one another, which is why the shadow looks so harsh right there. Don't worry about that. All I'm going to do is I'm going to say that the rotation, all right, let's do it 30 degrees with a factor of factor. Okay, you're not seeing anything, nothing is moving. And it's not just because we haven't pressed play. But let's press play. See what happens right now. Nothing. The reason nothing is happening is because there is a bug in Xcode 11, which has thankfully been fixed in Xcode 12, which is that if you have a custom shape that you are trying to animate inside a for each, then it won't animate in the internal simulator. It will work in the external one and on the device, but it won't work here unless you put it in a container. So that's what I'm going to do. I'm going to put it in a Z stack, because why not? And now we should see it animating, and there it is. Right, it's not exactly what we want. As you can see, it's rotating around its center. So let's change that by changing the anchor on this rotation. All right, anchor around the top. And now we should see that it's rotating exactly around this point, which is the middle of the top of the shape. Perfect. And now, if I uncomment these two, we should see our aperture animating perfectly. This is exactly what we want. Right, so the aperture's looking pretty good, and this is a good place to stop so we can pick things up in part 3, where we're going to be making things look pretty. We're going to add an orifice. We're going to be talking about inner shadows, and we're also going to revisit the debug aspect to this to make it nice and easy to redesign your blade if you want to. So join me for that. It's going to be brilliant. Don't forget to hit the like button. It really does help people find the channel, and it makes me very happy with your support. If you haven't subscribed yet, then consider doing that, because you really want to see where this one ends. Believe me, you do not want to miss it. If you have any comments or suggestions, please leave them below. But in the meantime, thanks for joining me. See you next time.